Okay, so Leetcode practice time. In this video, the two goals. First goal is to see how to solve this problem, and then we are going to put some code for the solution. And then the second goal is to see how we should behave during a real interview. So let's get started. So remember, the first step in the real interview is to always try to understand the problem. If there's anything unclear, please bring up the question to the interviewer to ask the interviewer to clarify, and also at the same time think about some edge cases. So let's take a look at this question. So balance a binary search tree. Given the BST, return a balanced binary search tree with the same node values. So a binary search tree is balanced if and only if the depths of the two subtree of every node never differ by more than 1. So if there is more than one answer, so return any of them. For example, for this one, after we rebalance, the BST is going to be like this. And the number of the nodes in the tree is between 1 and 10k. So the tree is not going to be empty, and the tree nodes will have distinct values between 1 and 100k. So okay, so let's see. Alright, so it says that we need to reconstruct the tree, but it doesn't necessarily need to be the original tree, like original node. Just the same node value is fine. So I would say if you want to a fully balanced BST, then a very simple way would be you just do a in-order traversal, and in this way, so during the in-order traversal we will have a list of the nodes, the list of the nodes value in sorted order, and then we reconstruct the tree. So for the solution, I think we could be like in-order traversal plus reconstruct the tree, like rebuild the tree. So in total, the runtime is going to be all of n. N is the number of the nodes within the tree, because in order traversal it's going to be all of n, and the for rebuild is going to be all of n as well. Alright, so let's get started and do some coding work. So after we find the code, the solution, and the interviewer and you agree on this approach, it's time for you to do some coding. So in coding part, speed is a factor to consider, correctness, and also the readability of the code. So let's do some coding. First of all, it is in-order traversal. So I'll define a something called in-order. In-order. So it will be the tree, the root, and we will have a list of the integer. So this is I would say this is list. So first of all, we will say list of integer sorted list, new array list, and then we are going to call in other traversal, passing the root and also the sorted list. So in this in-order traversal, first of all, we are going to visit it. First of all, define the exit of the recursive function. So if root is equal to a none, then we simply return. Otherwise, we need to do in order the root dot left and the list, and we have list dot add root dot value, and then in order root dot right, list. Alright, so that's the in-order traversal. After the in-order traversal, we have the sorted list, and it's time for us to reconstruct the BST. So I would say return build BST, pass in the list, and the range would be starting from 0 to list dot size. So it's okay, sorted list 0 to sorted list dot size, right? -1. Alright, so this one is the start index of the node value we are going to use. So we are just going to use the node values within this range from the sorted list to construct the tree. So that's so we are going to define the helper function, which is build a BST. So first of all, it is the list of the integer of the node values, and so actually this like node values is a better naming, I would say. So sorted, they will say this is no value, called node value. Alright, so start and the int and index. So first of all, I will need to get the middle. So mid is equal to alright, so if for this recursion, first of all we need to define the exit. So if the start is larger than end, we are going to we need to return the tree node. Actually, we are going to return a non-pointer. Otherwise, we will get int made is equal to start plus end and divided by 2. So we are going to say tree node root is equal to new tree node the value, which is node mouse dot get made, right? Alright, so and root dot left is equal to build BST on top of this node vals from start to made -1. And similarly, we are going to have the root dot right is from made +1 to the end. So yeah, that's pretty much it. And finally, we are going to return root. Yeah, so that's pretty much it about this code. After we are done with coding, it's time for us to do some testing. So let's do some sanity check by going through a simple example. So first of all, let's see this one. So for a in-order traversal, first of all, we call the in-order traversal to construct the node values list. So first of all, if it's none, then in-order first traverse the left tree, then the middle, and then the right tree. I think it looks good. And then we build so suppose we have a list of 1 2 3 4 four numbers within the node value. So we are going to build a BST. First of all, start is equal to 0 and is equal to 3. So the mid is going to be 1. So mid is equal to 1. So the root is going to be a value with 2. And then we call the recursive function to build the left subtree and right subtree. So I think mostly it looks good. Let's give it a try. So it seems to be good. Let's give it a submission. Alright, so everything looks good. I would say regarding the test case setup, definitely set up something like this. I think other than that, I cannot think of any special test case we need to include to make sure that we reach some certain branches, because it's a pretty general code. I don't see any special branches we need to test. Alright, so that's it for this coding question. If you have any question, feel free to leave some comments below. If you like this video, please help subscribe to this channel, and I will see you next time. Thanks for watching.